for today. How do you calculate the pH of HCl? I am so glad they had this. But let me just write the question down. To calculate pH of HCl. So I wish I could just copy and paste what I said earlier about the whole acetic acid. But the first thing I exactly want to do is find Ka to know if it's strong or weak acid, okay? So when we refer back to this table, hydrochloric acid HCl is all the way up here, and it actually gives an answer right there. Strong acids, Ka greater than 1, which is actually what all these are. These are the strong acids that we know of, hence why they're up there. So hydrochloric acid is a strong acid. In fact, I'd actually memorize that because hydrochloric acid is quite reoccurring in chemistry, and you just have to know it's a strong acid. So it is indeed a strong acid because the Ka is greater than 1. Okay? Now, with that being said, the formula now for dissociation would actually be HCl with not much need of water. But you can still add that there too if you want, but it'll just go like that. H plus Cl minus. You could also write this when it's actually reacting with the water, whichever one helps you see the dissociation easier. But it will be Cl minus plus H3O. Okay? And the reason why the arrows are like that, because it's a complete dissociation, okay? And either one will say the same thing, okay? But the point being is that to calculate the pH of HCl, because it's a strong acid, it's a 1-to-1 ratio. You don't even need that whole Ka formula. Whatever concentration, so molarity, whatever molarity you have of HCl, you will have the same molarity of the Cl minus. If you start out with 0.5, and the H plus, sorry. If you start with the 0.5 moles per liter of HCl, you'd have 0.5 moles per liter of that H3O hydronium ions, or just like that, quote unquote, the acid component. And then you just throw in your formula, negative log H3O, right? And you just factor in whatever value really you have. So if they give you like the grams of HCl in a certain amount of solution, as long as you can find the molarity of HCl in that solution, you have found your molarity of acid. So together with those two things, just throw that into this formula. And in this example, for example, the pH of that HCl, negative log of 0.5, the pH would all be all the way down at 0.30, which makes sense because hydrochloric acid is a strong acid, so it's really close to like 0. And exactly in this case they used 0.2, and when you do the same thing, negative log of 0.2, we have it rounds up to 0.7. So exactly, strong acids, it's just a 1-to-1 conversion as they showed here. Okay, every 1 mole of HCl, there's 1 mole of H3O formed. And they actually did use this formula as well of the second one. Either one works, like this one and this one, as long as you know that the H plus is the same thing as the H3O plus. Okay, but in terms of technicality, it is H3O plus. They're hydronium ions. It's hard to see like just proton just floating in the water. It's usually the protons being grabbed by other molecules to form things. Okay, and now for question 20.